finish this last page. Okay, find the slope of the tangent to the curve y equals sine to the fifth of x. Remember, we can think of this as sine of x to the fifth power. I recommend rewriting it so that we remember when we do the chain rule, what is considered the outside, what's the inside. So the outside is going to be the fifth power. So we're going to take care of that first. So 5 sine x to the fourth times derivative of sine cosine. Now we want to find it just says the slope of the tangent. So we don't even have to find the equation, just the slope. So we just need to plug in pi over 3. All right. So pi over 3. Ordered pair. So root 3 over 2 for sine, 1/2 for cosine. So I have root 3 over 2 to the fourth times 1/2. All right. Yeah, what's root 3 to the fourth?
9. 6 over 9.
9. So 9, so this will be 9 over 16. So when we multiply it out, it will be 45 over 32. All right. Example 6. Show that the slope of every line tangent to the curve y equals 1 over 1 minus 2x to the third is positive. Well, first thing, okay, I would rewrite this as 1 minus 2x to the negative third. And now, let's find the derivative. So, if it's saying we want to show that it's positive, obviously we need to find the formula for the slope first. Now, you could do quotient rule, but you still have to end up doing the chain rule anyway. So, what's that going to look like? Negative 3. 1 minus 2x to the negative 4 times negative 2. So if we rewrite this, it'll be a positive 6 over 1 minus 2x to the fourth. Okay, so what do we want to show? That the slope is always positive. Well, the numerator is positive. Denominator is positive, so right. So 6 is greater than 0, and 1 minus 2x to the fourth is greater than 0. Therefore, y prime is greater than 0. Okay, this last example was one of the problems, very similar to one of the problems in the homework. What's wrong? Why did we have to? So we're showing that the slope of every line tangent to the curve, so we have to find the formula for the slope of the tangent, and we're just showing that the slope is always going to be positive. So no matter what we plug in for x, we're always going to get a positive number. Okay, so yes, hopefully once we go over this one, that problem in the homework will make more sense. Okay. So we want the derivative of f of x times g of x at x equals 1. So that's just the product rule. So the first one doesn't actually use any chain rule, right? So it's just going to be f prime of 1 times g of 1 plus f of 1 times g prime of 1. Good with that? So f prime, okay, so now we just have to kind of figure out from the chart. So f prime of 1 is 5/3. G of 1 is 1 plus f of 1, 1/3 times g prime of 1. So 5/3 plus 2/9, 17. All right. Now we want to do the derivative of g of x over f of x at x equals 2. Again, there's no chain rule here. This is just quotient rule. So what is that? Low. Let's plug in 2. So low, d high, take high, d low, cross the line, square the low. Guess I should have left a little more room for these. These are very small. All right, so what is that going to give us? F of 2. What? We don't know what f of 2 is? It's 1. So it's 1 times negative 4 minus g of 2, so negative 1/2, times 1/4, all over, what's f of 2? 1, so 1 squared. All right, so what do we have? Negative 4 plus an 8. Well, we could do fractions, right? Close. Negative 31 over 8. We're so close. All right, this one I'm gonna try to write a little smaller here. Okay, this one is the first one where we're actually having to do the chain rule. This would be, if you think about, this would be f of x to the 1/2. So if I were to do the derivative of this, this would be 1/2 f of x to the negative 1/2 times f prime of x. Okay, so just kind of in terms of the formula, right? We're just doing derivative of the outside, keep the inside the same, right? And then times the derivative of the inside. Okay, so we want to do that when x equals 3. So that's going to be 1/2 f of 3 square root of that on the denominator, right? Actually, let me rewrite this. 1 over 2 root f of 3 times f prime of 3. Right, because it doesn't matter since f prime of 3 is 0. I'm just going to get 0 anyway. No. It's just, when I'm simplifying, I like to, like if you have a negative square root, I just put it in the denominator. Or negative 1/2, that is. Okay, f of g of x. This is just the chain rule. So what do we want? So if we were to do this, this would be f prime of g of x times g prime of x. So we want f prime of g of 4 times g prime of 4. Okay, so g of 4 is 1. So we want to do f prime of 1 times g prime of 4. So that's negative 1/3. Yeah, 5 over 3 times negative 1/3. So negative 5/9. Good. Are we getting the hang of this now? Kind of? No? Okay. What happened?
Why'd you do F prime?
Well, so I had to figure.
F, it's negative 4/5, not 4.
Oh, did I write down?
F prime of 4 is
F prime
negative
of
4/5.
No. What's g of 4 though?
Oh,
G of 4 is 1, so I'm going to do f prime of 1, which is 5/3, times.
Oh, that's what you do?
Yeah. So you have to remember when we're doing the chain rule, what we need to do is evaluate what this is first and then find the derivative of that. Okay. 2 more. So when it's written like that with the g to the third of x, we can rewrite that as g of x to the third. So what would that derivative be? It'll be 3 g of x squared times g prime of x. So if we're evaluating at 2, it's going to be 3 g of 2 to the second times g prime of 2. All right, so back at our table, g of 2 is negative 1/2. So it's 3 negative 1/2 squared times g prime of 2. Okay, so that just ends up being negative 3. Last one, g prime of 2. G prime of 2. So this is basically d, just backwards, right? So g of f of x. So this derivative will be g prime of f of x times f prime of x. So we want g prime of f of 2 times f prime of 2. So just like on part D, you have to figure out what f of 2 is first. And so f of 2 is 1. Wait. F of 2 is 1. What's f prime of 1/4? So 2/3